So the recorder is on, and it is recording from the right channel. I always check, because even though it's recording, sometimes the software setting is off, and it can be recording from the internal sound card, which has no microphone attached at this point. So it will still be recording silence in that case, or mechanical or not mechanical, electronic noise, coming from the computer. All right, so that's all done, and we can get into today's class content. Are there any questions regarding the homework assignment? Any questions regarding the process, or is anyone stuck in any particular step, not understanding the instructions or something like that? No? It's all good? Okay. So let me get to the website first. The reason why I changed before this semester, in the previous semester, last time I taught this class, I was using what Moodle calls a lesson in order to do the lab. The problem with the lesson is you cannot review it. Okay, you cannot just go back and say, I want to review all the questions. It doesn't let you do that. You have to redo everything with the right answer to move on to the next step. So you cannot just go back and say, okay, I want to read all the questions again, because a lot of the information is actually embedded into those questions. Okay, like the discussion of what is encryption, why you want to encrypt just the home mount point and stuff like that. Those are actually useful information, but they're embedded in the homework assignment itself. So when you have a quiz, then you have the ability to review it anytime you want. But let me just get back to the issue of having Linux having this quiz have only one attempt, because I really intended it to have an unlimited number of attempts. So we'll just go ahead and change that first. Oh, there we go. I goofed. There we go. So now we should be able to go back in and try another attempt. All right. So we are now moving on to topic 4, and topic 4 talks about client-side file sharing security and file system permission for users and groups to ensure correct access to resources. And this part starts with local file permission and ownership. So this is where we are getting into at this point. And this is a fairly long slide. I think we'll just probably be spending the rest of today, going through this slide here. And your next homework assignment will be based on, this part here. It's basically how do we configure the permission of files, and how do we configure folders so that we can actually lock up certain things, so that some people can look at it and other people cannot. Okay. Now, files are particularly important. I'm not even reading from my own notes at this point. Files are particularly important in Linux or in any modern any modern operating system. Operating systems like Linux, BSD, and even Windows these days are all file-based. In other words, they try to make everything look like they are just files. So that means understanding how files are implemented, and also how to protect files from people who are not supposed to access the files is actually important. In Linux, a file has the following attributes. Other than the root directory, every file and directory has a parent folder, and that's not actually true, but every file at least has a parent directory. In other words, it belongs to a particular parent folder. Are we doing okay so far with that concept? Now, it seems really obvious, okay? Every file or every folder has a parent except for the root folder itself. But this is actually important because the way Linux stores information in a folder okay, I take it back. The way Linux stores information about permission is not on the file itself, it is actually in the folder, okay? So that's the important part. Every file has a name, and that is not exactly true, but every file has at least a name, okay? So there's a reason why it is written this way, because in Linux, you can use a hard link so that a file can end up with different names. In different folders, having different names, but they can refer to exactly the same content on your hard drive. Okay, it's called a hard link we may or may not have enough time to talk about that, but it's something that you can keep in mind, because it can give you the pretense that, oh, I have this file, but then that person also has the same file. But if you delete yours, it will also, if you make modifications to yours, it will also make modifications to the file of somebody else. And it's not just a sim link, it's not a symbolic link, it is a hard link in that case. Every file has at least one user owner, and the reason why I use at least is because it depends on whether you turn on the ACL extension in the Windows, in the Linux extension 2, extension 3, and so on file system. You can end up with multiple owners, user owners. But we'll talk about at least the basic implementation first, and then we'll talk about the ACL extension to that. Every file has also at least a group owner, and every file has what we call, quote unquote, a other owner, which refers to any user in the system that is not a user, that is not the user owner of this file, and does not belong to the group of the group owner of the same file. So all of those users basically fall into the category of others. Okay. Every file has a read permission for each of the owner. So that means the user owner has a read permission flag, the group owner has a read permission flag, and then the other owner, which refers to everybody else, also has a read permission flag. And the same thing applies to write permission, one for each owner. Execution permission applies to one for each owner. And it also has an interesting feature called set UID or set user ID, and that one is either on or off. So you can look at it as a flag as well, because you can either have the set user ID flag on, or you can have it turned off. Are there any questions at this point about the overview of attributes associated with a particular file? And for the most part, folders are files too. Okay. No questions? All right. So the next paragraph or next section talks about what is a user, what is a group, and what is other. I kind of briefly go over that, but this one treats it with a little bit more detail. A user is an entity represented by an entry in this particular file. In fact, you can probably take a look at that file as a regular user. Okay. Some people would look at it and go like, wow, but it's a password file, how can it be open to everybody to read? Well, let me take a look at the one in this particular system. Even though it's a live system, it works exactly the same way as all the other systems. So I can look at etc/passwd, and everything is in plain text. And you look at this file and go like, but I don't see anything that resembles password or the hash of a password or anything related to passwords. That's exactly why this file is not protected, because the password file, or what we know as the password file, is really just remembering things that are not really top secret. I'll pick one entry here. Let me pick my typical user, which is down here. Okay, the last entry. So let me change the screen size so we can see a little bit better, especially for people in the back. Okay, so if you look at this line here, there you go. We were missing one part of the screen. So if you look at this file, it has it states several things. Right here, user is the name of the user account here. So that's the name, that's the symbolic name of this particular user. Each entry is a user. So in this case, we have a user with the name of user. 1000 and 1000, that's actually referring, the first one is the user ID. The second one is the group ID related to this user. And then we have several attributes, which are basically the name of these entries correspond to the name of the user. When the system sets up the user account, it doesn't put in anything like last name, phone number, and stuff like that. So that's why you just see commas in place of that. Next, we have the folder, the home folder of this particular user. In other words, as soon as this particular user logs in, the command prompt will be placed in this particular folder, /home/user, which is a very typical place to put user account, is under /home. And this is also from the discussion of Tuesday. Remember on Tuesday, we kind of talked about why you only have to encrypt the mount point /home, because that's actually where user-oriented files are, user files are stored. The last one is called a shell command. So that means, when I log in as user, okay, either through a terminal, SSH, or some other means, it will use bash as my login shell. Okay. Now that doesn't seem very important, but it is, because if you look at some other users, for instance, if you look at ClamAV, which stands for Clam antivirus, you can see that it has a kind of strange home folder of /var/lib/ClamAV. It is not under /home, but more importantly, the login script is /bin/false, which basically means there's no way for someone to log in as ClamAV and be able to interact with the system. So any user account that is not supposed to correspond to a real user should use either false or no login as the login script or as the login shell, so that those accounts cannot be logged in. You can SSH and try to log in as ClamAV, you cannot do it. Okay, even if you know the password, even if a password is set up for ClamAV and you know the password, you still cannot log in and get any control because there's no shell to run your command. Okay, so that part is definitely related to security, because you only want to turn on a shell for accounts that really need to log in and do something. Yep.
Why does he even have a user account?
Because you have the setup permissions. So that's the only reason why ClamAV is set up as an account, because when you run a program, you're running that program as a particular user, and that is also a security feature, because you want to basically say, okay, we do not want to run programs as root as much as we can. So if we are not going to run the antivirus daemon as root, who are we going to run that program as? Well, in this case, we just run it as the user ClamAV. And then by doing that, we can limit what that program can do. ClamAV is only supposed to read a lot of files, but it's not supposed to be able to overwrite files. So we can set up all those permissions appropriately. All right. And there's also an account called Nobody with a home folder of non-existent /non-existent, which guess what? Is non-existent. Exactly. There's no such folder. So when this particular user even logs in and tries to go to the home folder, it would just generate an error because there's no such home folder for this particular user. Okay. Are there any questions at this point about this file and all of these users? Okay. No questions. We can come back to this one when we need to. In the meanwhile, we are just going to continue the discussion here. A user has several important attributes. It includes, the first one is the UID, which is the number. The default user has a number of 1,000. Okay, all of the other accounts are way before 1,000. So 1,000 is the starting point of end users that are corresponding to people who are actually logging in and using the system. Can anyone guess what is the user ID of root? Root being the very first user that exists in the system has a user ID of 0. That's right. UID of root is 0. It includes a path to the home directory and various other attributes. The home directory is a convenient feature as it specifies the default place to be at after a user login. Now, in this case, logging in through a GUI is not really what this sentence is intended to. It's not the context for this particular sentence. When I use this sentence, it refers to logging in through a command line interface. Because if you log in through a command line interface, at any time there is a concept called the working directory or the current working directory, and if you log in as a particular user, the current working directory is specified, and usually it is placed as the home folder. A user can log into a system, and typically you can do that using password authentication, although that is not the only way you can authenticate to log into a system. Now, this part is important because a group cannot log in. A user is the only entity that can quote-unquote log into a system and start to interact with the system. A group cannot do that. So a group is strictly a concept used to basically say, okay, instead of applying this type of permission to a single user account, we can apply that to a group of user accounts. And then this part is just basically saying, after a user logs in, we can put it into a shell, assuming the shell is set up to be bash or some actual shell and not false or no login. Are there any questions about this part? Now, how do we know what is no login and what is false? Well, one quick way to find that out is to run it. Okay, you can run false as a command. It doesn't seem to do a single thing, right? You can run no login, and it's not even specified as a command. That was actually intentional, so that any account with no login as a shell setting can try to log in, and it doesn't even correspond to a file in this case. But what about bash? Okay, I type bash, it looks like nothing happens either. Well, what do you think? Okay, now this is not obvious because when I exit, it's the same place. If I change my current working directory to temp in the original bash and I run bash again, it preserves that. Okay, if I exit again, what do you think will happen? This is my bottom level bash already with this terminal.
Should close your terminal.
That will close the terminal. Okay, so that means if I run bash on top of bash, it is not visible, but it is there. Okay, the second level of bash is there, and I will be starting to interact with the second bash and not the original bash. Okay, the other thing we can also do, to kind of illustrate that point, kind of goes back to what we talked about last time, using PS to look at all the process IDs, and then use --forest to see who is a child process of whom. So that way we can actually quickly identify all of those things. So let's go ahead and use PS -af -forest bar less, so that we can look at all the processes. And we're looking for the one that is running PS right there. All right, so this is good. Okay, this is really helpful because it's showing me that I have several bash sessions, and these are all coming from XFCE4 terminal, which is this application itself. The containing application running all these bash shells is the XFCE4 terminal. And you can see that we have several bashes here because we have 1, 2, 3, 4, 5 at least, and one is actively running FFmpeg, and that's that FFmpeg here, and that's why you see kind of like a red symbol here, because any screen that is updating, has content changing, is highlighted red, so that you can tell, oh, okay, that terminal has something I haven't seen before, and if we click there, you can see that it has a lot of stuff scrolling, and that's why it is appearing in red when it is not the current focus. Okay, but getting back to what I really want to illustrate is this is the bash that is running the PS command. And you can tell that the bash running the PS command has a process ID of 4152. Okay, let's remember 4152 here. So what we'll do next is I'm going to quit from less, and then this time I run another bash. Okay, so I'm running on one bash on top of another bash. Okay, so we are double bashing now. And then we'll run the same command again, ps-af-forest bar less less, and we look for the two bashes, or we look for that process ID 4192. Here's the process ID, or did I get it wrong? Four one five two.
52, yeah.
Oh, okay. Let's look it up again. 4152.
Yes.
Okay, thank you. There you go. Do you see how 4152 was the old bash, or the low level bash, and then it becomes the PPID, or the parent process ID of another bash that is the current one that I'm interacting with, because you can tell the PS and less are both run by the second bash. So this is showing you that bash itself is interactive, and we can start a bash on top of bash. And that makes it kind of hard to see which bash we are running unless you look at the relationship of these process IDs. Are there any questions about what is being shown here on screen? No questions? Okay. All right. So, but when you run false, it's not the same thing. Okay. If you run false and then you look at the process ID, you can't even find the process that is started by false because it starts up and then it immediately goes back and say, nope. Okay, there's nothing to do. Now let's talk about the group. The first paragraph, which is this part here, talks about what is a user. The second paragraph talks about what is a group. A group is basically an entity represented by an entry in this particular file called /etc group. Let's go ahead and take a quick look at that group file at this point. So I'm going to get out of here, get out of my second bash, and then we'll take a look at etc/group. And this is what it looks like. The first part of each line specifies the name of a group, but it doesn't specify the GID because the GID or group ID is also specified by the PASSWD file. Okay, this one only uses the symbolic name of a particular group, and it tells you. No, I take it back. It does give you the group ID as well, but it also gives you a list of members of that group. So in this case, dial out is the name of a group, and user is a member of that group. In this case, we have audio. Audio is the name of the group, and then we have two users, in this case, two members. The first member is called post for post audio, and then the second account is the user. Okay. Are there any questions about how to read this particular file, or to determine who is a member of which group? Go ahead.
Can you edit that file at the top as to where you put in usernames on group?
You can if you want to. You can say, you cannot do that when you're just a regular user. So you have to elevate to to root in order to add membership to a particular group, or remove membership from a particular group. That's a good question. And let me see if there's anything really interesting here. No, this is a live setup, so there's really nothing too interesting. Okay, so we'll just do it up to this point, and then what we'll do is continue the discussion of this particular paragraph. Unlike a user, a group has no directory and it has no password. Okay. In other words, a group is used strictly as a container of users. That's all it's going to do, is to say, okay, what is the membership of this group? You can have zero membership with a particular group. In fact, many groups have zero membership. Okay, it doesn't belong to anyone. No one belongs to that particular group. And because there's no password and no home directory, I guess you can probably deduce that a group cannot log into a system. Okay, you cannot use the name of a group to log into a computer. A group has user memberships. A user can belong to any number of groups. For instance, user is belonging to quite a few groups, because that's the default user, and the group membership is needed in order to do certain things. A group can also have any number of users, from nothing, like zero membership, to all the users in the system. Are there any questions at this point? No questions? Okay. Okay, there was a question. Go ahead.
If it doesn't have a login, what's the advantage of the group?
A group is used so that if you want to specify a set of permissions to a file, but it does not apply to everybody, which is quote unquote other, and it does not apply to the user owner of the file, you can use group to basically say, okay, these people or these users can have certain permissions to this file, but it's different from the default, which applies to everybody, or the one that applies to the user owner of the file. Okay, I can give you plenty of examples later on. Okay, but that's the primary purpose of a group, is to allow you to set up permissions that is not applying to only one single user, which is the single user that created the file usually, or everybody else. So it gives you something in between and say, well, these users or users belonging to this group has a specific set of permissions to this particular file.
So it allows you to assign permissions in aggregate.
Correct. It also gives you the flexibility of, if you add any additional users later on and you want to say, okay, this particular user, like all the other people, should have access to the audio devices of this system, you just have to add that user to the audio group of the system, and you're done. Okay, you don't have to look up every single file that belongs to audio and then have user to also have that particular user to gain control to each and every single file. You just have to add that user to the group audio, and you're done, because audio is the group owner of of those files. So it gives you a lot of flexibility when it comes to specifying permissions to different users. In most systems, for each user, there's a group of the same name, and furthermore, a user by default is a member of the group of the same name. So I'm going to tell you exactly what it means and show you where you can find that. Okay. So let me look up user here, and user is the member of many groups. But guess what? User is also, not users, but user. There you go. So user is a group itself. Okay, so user is both the name of a user. Okay, I know this is bad, but it's also the name of a group of the same name. Okay, and by default, user is in the same group of user. So you don't have to. So you don't have to add that membership. It's usually already there.
It sounds like Sean Russell's paradox.
It doesn't have to be. Okay, because in most cases it doesn't even make sense to have user to belong to user's own group, and we'll talk about that later and why it does not even make sense, for that to be the default. All file access must be initiated by a process that was started by a particular user. Okay, so let's talk about this part here just a little bit. Okay, and in fact, we'll limit it to this part here. Every process in your system is associated with, quote unquote, a user who started that particular program. And remember what a process is? How is a process related to a program? A process is a program. Go ahead.
Waiting for a request input.
That too, but a process is technically a program
In action, running.
in execution, in action, exactly. Okay, but somebody has to start that program running, right? So that's why every process has a user associated with it. Basically, it says, okay, who started this program? And depending on who is starting that program, that will determine what this program can do with the files in your system based on the permissions. Are we doing okay so far with that concept? When you look at a program in execution, not the program as a file, but when you look at a program in execution, whoever runs that program will determine what that program can do with other files. Okay, we'll take a look at this concept. Okay, I'm going to start up two processes here. Get out of here, and I'm going to switch to the root account here. So SU to my root account. Wrong password. And it's still wrong. I think I forgot my root password. That's okay. I can rescue. That part is easy to rescue, and I can even show you guys how to do that. It's easy thing to do. Well, I can add another user, like just use that as a test. Okay, I'm going to add a user called just with my last name, and because I cannot change to root, I cannot add a user. Okay, there we go. For whatever reason,
okay.
I think I know what.
Did you use Sue to get
Sorry?
root? Did you just Sue to get root?
Yeah, I use switch user to change to root. I forgot that I removed all the files in etc. that included all the password files, so everything went back to the default password, and I was using my own usual password to try to get access. Okay, so from here, this bash is now running as root. The other bash is running as user itself. So let's take a look at the processes and see if we can find anything related to what we just talked about. Okay. This time I'm not turning on forest because there's really no need to do it. You can see the UID part here. UID once again stands for user ID. So you can tell that the init command is executed using root access. Okay, and we can see that most of the processes were started by root, and then we have some really strange ones, started by, in this case, Avahi, and that's the Avahi daemon running here. And then we have, we should start to see more more processes started by the user account user. X session manager is responsible to restore a session and also keep track of a session in X window or in any type of X window desktop. That is started as a user. Let's see here, and then we have a whole bunch of bash sessions also started by user. So you can see that these bash sessions were started by user, and there should be one bash started by root because I just did log in as root in that place. So we'll go ahead and look for root at the beginning, and there we go. So you can see the su command is still active, because su does not get out until I exit from that shell, and the shell started by this process. You can see this process ID becomes the parent process ID of bash, and that one is started by root. Okay. So I'm just hoping that I'm using this to illustrate the fact that every process has a user associated with it, but not a group. Okay, a group cannot start a process, cannot execute a program. It's only a user. And also, this also illustrates, who can start a particular program. In most cases, is general. Okay, because I have bash started by user, but I can also have bash started by root. But depending on who started that process, it determines what I can do and what I cannot do with that process. Are we doing okay so far with that concept? Okay, file access control is based on the user associated with the process, not just the process itself. Okay, any questions? Questions? All right. Did you see a GID, with a process? Okay, let's go all the way to the top here. There's no GID. A process is not associated with any group ID. There's no group ID associated with a process, just a user ID. All right. So we are almost getting there. Okay, we are getting to the details of permissions now. All file access must be initiated by a process that is starting by a user. So the process is started by a user, and then the file access is determined by who started the process. We'll use x, lowercase x, to represent the user who is attempting to access file f, and the following logic determines how the user determines the following logic describes how the system determines the permission. Okay, so we'll take a look at this sentence here. For each user owner f of user u of f, do the following. So when you're running a file, running a process, it will go through each user owner and it will ask this question: does u match x? Okay, so once again, what is x? X is the user who attempted to access the file f, and u is the user owner of the file itself. Okay. Are there any questions about this part? It's trying to match up the two, okay? When a process wants to access a file, the first question it asks is the owner starting the process the same owner of the file? That's the first question that it's asking. Okay, I'm phrasing it in a way that is actually more difficult to understand than it needs to be. And if so, it's going to use the permission of that particular user because we have a match of the user owner of that file. If no user owner matches X, which is the user or the user who runs the process that is trying to access the file, then we'll move on to the group. For each group owner G of F, do the following. Because there are multiple group owners, but at this point let's just limit to one single group owner. So in this case, it will look at the group owner of that file and then look through the membership of that group and say, okay, is the user who is running the process a member of that group? If so, the group permission would apply to this transaction. If the first few steps all fail, in other words, the user running the process trying to access this file does not match the user owner of the file or is a member of the group owner of that file, then we'll have to use the permission that applies to quote-unquote others. Okay, are there any questions about this? We'll go through some examples. Okay, we'll go through a few examples so that we can actually go through this logic here. Let's take a look at. Okay, do you guys want? Can I switch screens? Okay, so let's switch screen to the shell again, and this time we'll go to this is one kind of special folder here. /dev has quote-unquote files, but they are not really files. They're really representations of hardware devices for the most part. Okay, some of these are logical or abstract devices, but most are actual hardware devices. So if I do an ls, you see, wow, there's a whole bunch of stuff here, okay, including your drives. Okay, so if you look at just SDA, exclamation point, you can see that I have SDA as an entire drive, SDA1 to SDA5 being partitions on that particular drive. Somebody in this class is going to say right away, it's going like, well, but any drive can only have 4 partitions. How come this one has 5? Well, one of these is an extended partition, so it can contain additional partitions inside the extended partition. But that's not even important at this point. What is important is I want to use ls-l, which means long, to look at all these files. So this way I get more information about these quote-unquote files. Are we doing okay so far with these concepts? Okay. So ls by itself, can show you the files, just the name, but it doesn't give you a whole lot of details. When you use ls-l, then it gives you a lot more information. So in this case, I'm getting quite a bit of information here. The first part here, let's not worry about this part yet, okay? Because we want to determine how does it know whether user, as a user account, have access to this file. Can I overwrite the entire internal hard drive right now using DD? Okay, that's the question. Let's take a look. This is the user owner of the file of SDA, and I am user. Do they match? No, does not match. Okay, so if I run a program, it'll be running as I'll be the owner of that process, and it will try to match me with the user owner of the file. And since they do not match, the permissions applying to root does not apply to me. Okay, all right. So the next thing we want to do is to look at the group owner of this file. The group owner of this file is the second item, which is disk. So now the question is, am I a member of the group disk? That's the question. Okay, and I think I am. Okay, how do I know whether I am or not? Well, there are several ways to do it. The quick and lazy way to do it is to use grep, which is a fairly useful Linux command, or in any type of Unix type operating system. Grep allows you to find a particular pattern in a file. So in this case, I'm just looking for the pattern, let's say disk in etc/group, because that file defines all the group memberships. Okay, press the enter key, and it says that I am not a part of that disk. I'm not a member of the disk group. Okay, so once again, I am not the user owner of the file. I am not a member of the group member of the file. So what applies to me is others. Okay, I am considered the other users, as far as this file is concerned. Are we still doing okay so far with this concept? Okay, but okay, now that I have determined my quote-unquote ownership as it is related to SDA, what can I do to this particular file? Can I trash the internal hard drive, because, I can run DD on it? Well, this is where it depends on the first part of the file. Because the first part of the file tells you a lot of useful flags about this particular file. The first letter, which is B, says it's a block device. It is not important to us as far as this stage is concerned, so we're not too concerned about what is a block device. The three letters, the three characters after the first one, so we're talking about the second character, the third character, and the fourth character, they tell us what the user owner of the file can do. In this case, the user owner is root, so it's basically saying the user owner root can read and write this particular file. Execute really does not make sense in this case because it's a block device, so it's not even a file that you can execute, it's not a directory, so it doesn't really apply. So read write is what the user owner root can do to this file, but I cannot do this because I'm not the user owner, I'm user. Is that okay so far? So that's good. It's good that the root can do whatever he or she wants, but since I'm not root, I'm moving on to the group part here. The second three, or the next three characters, RW dash in this case, is specifying what a member of the group user can do to this particular file. Well, unfortunately, it does not apply to me either because I am not a member of disk. Okay, so all members of the disk group can also read-write this file, but I'm not a member of that group, so it does not apply to me either. And because I am not the user owner and I'm not a member of the group owner, I am the other. So the last three characters, which is these three, apply to the other users. In this case, it's dash 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 instead of RWX, so that means I have no permissions to SDA whatsoever. I cannot read from it, I cannot write to it, and that's it. Okay, I have no access to that file. Now, how do I make sure that that really is the case? How do I test it, but without risking damaging the disk itself? Well, I can always try to read it, okay, because read is not destructive. If it fails, hey, okay, nothing is done. If I'm successful reading it, well, maybe I should revisit what I just said, right? Okay, so let's do that. Let's try it. I'm still user at this point. How can you determine who you are when you are not quite sure because the command prompt itself is all messed up?
Grammar.
Yep. There's a command called exactly who am I, and that will tell you who you are. Kind of philosophical. All right. So I am quite sure that I am user at this point, and according to these permissions, I cannot read or write to SDA. I cannot read from nor write to SDA. We'll go ahead and try to read from it first, okay? And DD can do it. There are many other ways to read from the file, but I'm just going to specify DD if equals /dev/SDA, and the output is just going to be the null device. In other words, I'm reading from this device, and I'm sending all the bytes that I'm reading to a black hole. That's it. Okay, null. The null device is basically a black hole because whatever you send to the null device is just disappears. Okay, it's destroyed. Okay, so this operation is harmless. Okay, even if I can read from the hard drive device itself, this operation is harmless. It's not saving it. It's not sending it out of the system. It's just seeing whether I can read from it or not. Press the enter key, and it goes like, cannot do it. Permission denied, which is correct. Okay, this is the way it's supposed to work. Are there any questions at this point? Okay, so next I want to try something, right? I want to say, okay, but what if I add myself as a member of the group disk? Then I should have read-write access to it. Okay, let's try that. The command to add membership is also add user, which add user can do two things. You can add a new user to the entire system, or you can add a member you can add a new member to a group. So you can use it. You can use add user for both purposes. So if I want to add a user to a group, then I specify the name of the user and then also the name of the group like this. This will fail. We tried this already because add user is not a command that a normal user can run. Only root can run this command. Okay, that's fine. I already have one terminal running as root, so I'm going to run it here. Add user, which is the name of the user in this case, and I want to add this user, which is usually what I use in the system, to the disk group here, disk. Okay, you can see that it confirms that it's adding user to group disk, and it's done. And if I come back here, excuse me, it should be successful in this case, but it's not going to be successful. Okay, let me show you first. Let's confirm that this is not going to be successful, and then I'll explain why it is not, and then we'll try to fix it. Okay, we'll find a way to fix this problem. Press the enter key. It's still denied. Okay, what is going on here? Okay, well, maybe I did not really add myself to the group properly. Let's check that first. Okay, so we'll go back to the previous command of the grep command here, and it is clear that I'm now a part of this group. So what is going on here? What is going on here is when I first ran this bash shell, it is running with me not being a part of that group, and bash as a program is still running in that state. As a result, the system does not understand that the group ownership has changed at this point. So that's why if I use the same bash or the same shell to run a command, it does not get the update of add user at all, and that's why it's not working. Okay, so that means if I do a new tab here, Control Shift T would open a new tab in the terminal. This time it should work because this is a brand new bash after I add user to the group disk. So let's repeat that command: dd if equals /dev /sda of equals /dev /null, and it's still complaining. Okay, maybe I have to log in again. Okay, start a new shell. They're all coming from the same shell, so it's possible this is why it's not working. Yep, it's still not going to work because we are still starting everything from the original shell, so it's not going to work. Let me try to find another way to get around this one. Let's use SSH to SSH back into the system. Cannot resolve local. All right, so this is a brand new shell. It's not coming from before. It's not the shell. It's the login. That's controlling this part. But this is a fresh login. So we'll go ahead and try that again, and this time it should work. dd if equals /dev /sda, and it does work. Okay, so what is changed? How is this different from the other bashes? Let's figure out. While dd is doing its busy work, copying probably hundreds of gigabytes into a black hole. That's a lot of work. All right, so we'll do a ps-af and go through less. This time I'll turn on forest too, just so that we can see who is whose child process. And this time is I would look up dd first because where's dd? Okay. I'm looking up dd as a command. Right there. Okay, so there you go. All right. So we have dd here as a command. It is coming in from SSH. So it's not coming from the same shell as the other one, and that's why it is working. Because all of the other shells, they come from the same source. You see all of these shells here, they come from the same XFCE4 terminal, which in return come from X Session Manager. It comes from Light Display Manager, and it comes from here. So I'm thinking that the group ownership, got locked down, at the early stage. So no matter how many bashes I start, it's still going to inherit the group ownership from the processes that were run before. Whereas the other one is started from a SSHD, which is different, and then the login session is this particular bash here. So it picked up the group ownership correctly because it is a fresh run of bash. It is not something that is run from a previous process or an existing process. So you might run into this kind of problem, when you play with ownership of groups and stuff like that. So what you need to do is either to log out and log back in again, or use a different terminal to do it. A different terminal will for sure fix that problem. Are there any questions about this? Is everybody familiar with SSH or how to use SSH in Windows? If not, okay, that's okay. I mean that is what I was asking, just so that I know whether people want to get some information. Your virtual machine, if you set it up the way I specify it, it would have SSHD or the server of SSH already installed. What that allows you to do is to open up a terminal or additional terminals to the virtual machine. So this way you can have multiple consoles open at the same time, and you can run one using man command, and then the other one using ps, and then the next one actually running the command that you need to run. And to do that, I'm running Linux here, but you can do about the same thing. What you need to do is to install a SSH client program. Okay? If you want to look for a SSH client program, the one that I use the most is called PuTTY. So if you combine PuTTY and SSH, you can find the actual home page of the program itself. Yep, this is the home page. We landed on the right page here. This is the home page of PuTTY, which is a free telnet/SSH client. What it allows you to do is to open up an SSH connection to a computer with SSH server running, so you can open up a terminal to that machine remotely. This is really, really useful, especially for your homework purposes, because now you can open up multiple terminals, and then guess what? Copy and paste also works. Okay, if I give you a long sequence of commands, on my web page, you can copy and paste it from the browser to the PuTTY terminal. Question? Okay. Now I cannot show you exactly how to run it in Windows. It's not any different from running all the other commands in Windows, so I'm not going to be too concerned about that. But I do want to show you what it looks like when you run it. And I do have SSH installed on this particular machine. And it looks like this. Okay, when you run it the first time, it looks like this. You can basically save sessions. A session is basically remembering the font size that you want, the background color that you want, the host name, the port number, and so on and so forth. It's a handy feature so that if you have preferences, you can save those preferences. Yep.
You can enable shared clipboarding VirtualBox settings.
Oh, you can? Oh, nice. So you can copy and paste, using the, okay, that's good. Thank you. So in this case, I'm going to connect to localhost, which has an IP address of 127.0.0.1. But when you do that using VirtualBox, it'll be slightly different. Okay, we haven't really talked about the different networking mode in VirtualBox, so we'll have to talk about that first, in order to do your homework assignment. But without doing that, I can say 127.0.0.1. That's my localhost, and this machine is already running Linux with SSH server enabled, so that's why I can do this. When I open up the connection, you will see exactly what is displayed here. The first thing it will ask is, I have never connected to this host before, so it's basically asking you, can you confirm the RSA2 key fingerprint is this? Okay. In a high security type of setting, you better double check to make sure that the fingerprint is what it is supposed to be. In other words, you have to ask the system administrator and say, what is your RSA2 key fingerprint of this particular server? And when it pops up this screen, you match it. In this case, it's irrelevant, because what am I connecting to? Can I trust localhost? I sure hope so. If I cannot trust localhost, then I'm really short to begin with. I should not be teaching this class at all in that case. Okay, so you can click accept once you double check this and say, okay, it's all good. And it will give you a login terminal. Login as. You can give it a username. Whatever username you set up on your system is what you give it. And then your password. And then you log in. And you can do this as many times as you want. So you can fill up your entire screen with PuTTY sessions. Yep.
And you want to verify because you don't want to enter in sensitive information that could be not that server, right?
Because you don't want to be in the middle of a man-in-the-middle attack. In other words, someone. Okay, if you say I want to SSH to, let's say, drtech.org. Okay, and let's say drtech.org is a legitimate website, and you're supposed to make connections to it. But if someone messes around with a DNS server, they can remap drtech.org to another IP address. And if you make a connection to that other server, then you're not making a connection to the server that you're supposed to connect to. And that's what the fingerprint is about, is to make sure that you are connecting to the server that you're supposed to connect to.
And they can do malicious things to your machine just by connecting?
Mm.
Or is it just this steal
Okay.
information that you actually enter in?
Well, I don't think it's easy for the server, the malicious server, to back hack onto the client computer.
Okay.
It's not easy, not meaning it's impossible. There was one update of PuTTY which was due to an exposure like that. So at one point, yes, there was a bug, that allowed a malicious server to back hack the client computer. But those are very rare and very uncommon. So most of the time you cannot, go backwards, okay? But nonetheless, you'll still be connecting to the wrong server. And the server, if you use the password authentication, the server now can log your password. Of course, you won't have an account on the fake server, but they can change the way SSH interact with you to basically make you think that you're making a connection. So whatever type of password you type to authenticate into the system, they just log it. So now they know your username, they know your password to the actual drtech.org server, and they can now use that to gain entry or into the actual server. So that's why it can give you problems down the line, but it's not because the malicious server can backhack onto your client computer.
Can they do like reverse shell or something?
I don't think SSH supports that.
Okay.
Yep.
Actually, no, never mind. I think you can. It's just
You have to use a port forwarding for that to happen. So you have to forward port 22 to the remote server, so that the remote server can say, okay, when I open up port 2222, it corresponds to port 22 of your client machine. But you still require your client machine to have SSH server to be running for it to make that connection. So for the most part, you're just making sure you know the identity of the server that you're connecting to. Okay. Are there any questions about this part, using PuTTY to make a connection to a remote server? No questions? Okay. I think we'll just go ahead and continue the discussion with permissions, and when it's time to do the homework assignment, I will give you the information that you need to set up the networking mode of your virtual machine, because that's also one big piece that you will need. So at this point, we're going to go back to the discussion of permissions. Oh, that's the wrong slide. This is subroutine tracing, so let me just get rid of it. All right, so we have permissions, access request versus permission. There are three types of permissions or requests that a program can make to a file. The first two are fairly easy to understand. You have a read access, okay, or read request. So the program in execution wants to read the content of a file. That's pretty easy to understand. Write access, the process wants to change or create the file. Okay, that's easy to understand too. Now execute is a little bit strange, because the process wants to run the file. In other words, it wants to start another process or switch out the current process to whatever the file that you want to run to become the new image of that process. But that's just basically running a program, executing a program, and that's another type of request. Are there any questions at this point? No questions? Okay. How everything is represented in ls-l? We just kind of talked about it. So this is just a breakdown of all of those things that we just talked about using this particular example. So I'm not going to get into too much details here because we just talked about it. Now in this case, it's a little bit different. Because when you look at this particular line from ls dash L, the first letter starts with a D instead of a dash or a B. A D stands for, this is a special file called a directory, okay? Otherwise known as a folder in Windows land. But in Linux, it's called a directory, and it's basically a folder. In other words, in this case, test is the name of the file, but it is a directory. Now, when we're talking about a directory, now we suddenly have a kind of strange concept called, but what is the X or executable flag? What does it mean to a folder? I can understand when it's a file, okay, I can run the file, I can start a bash program, I can start a script, and so on and so forth when it's an individual file. But what does it mean when it is applied to a folder? Okay, well, as it turns out, the X flag has a different meaning when it is applied to a folder. Okay. Now, in this case, I just say that it has, the group owner has all except for the right permission, and the other owner also have all except for the right permission. I didn't quite explain what is the X permission, and it's deferred down here because it takes a little bit of text to describe what the X flag really mean when it comes to a directory. The X flag means it doesn't mean read. It means having access to the content of the folder. Okay, so what we want to do now is not to read all this stuff here because it's kind of dry, but instead we'll imagine there's a room. Okay, so we'll imagine there's a room and it is transparent. It has a transparent walls and a transparent door. Okay, so let me just pick up a pen and draw something here. So here we have a room, and it is completely transparent. Okay, the enclosure of the room is completely transparent. It has a door. Okay, so with the door, someone can open the door, go inside, but you can see everything from the outside as well. On top of this room is a huge light panel here, and you can turn on the light, you can turn off the light. Okay. All right. So here's the lock, and here's the light with a switch here. Okay. What read means is this thing here, the light switch. Okay. If you can flip up, if you can flip on the light, then you can, from the outside, you can see what is inside the room. Oh, I can see there's a TV here, there's a table, there's a chair. There are these things that are valuable and junk over there. Okay, so you can actually see the content inside the room. But can you get into the room and start to mess around with stuff? Not necessarily, because the room is locked. So even though it has a transparent enclosure and you can see everything inside because the light is on, doesn't mean you can actually get the stuff in the inside. You just know what is inside. This is the read flag, the R flag. The X flag, which is access to the content, is here. That's the lock. Okay. With the X flag turned off, that means you may be able to see what is inside, but you cannot access those items. Now you can have it reversed, okay? Because with this, you have 4 combinations. So think about the 4 combinations of between R and X, okay? Right simply means you can go in and you can modify content in the room. So we'll talk about that next. R can be, I'm going to use 0 here to mean it's off, can be on. And when R is off, X can be off, can be on. When R is on, X can be, can be off, can be on. So we have 4 possible combinations. The first combination means the light switch is off, the lock is locked also. Okay, that means you cannot see what is inside the room, and you cannot walk into the room either. Okay, it's the highest level of security. In other words, this folder is now protected, completely protected. What about the next one? The next one says the light switch is off, but the lock is unlocked. Okay, because to execute permission means you can actually get into the room. Now, is that really protected or not? Not entirely. Okay, because if you, for whatever reason, know what is inside the room without turning on the light, you can still get into the room and access those items. Okay. What about this one? This one means you can turn on the light of the room and see what is inside, but you don't have the key to get into the room. So you have the exact opposite. You know what's inside, but you cannot touch anything in the inside. Okay. The last one obviously has the least security, because now you can turn on the switch, see what is inside, unlock the door, go inside, and touch those items. Are we doing okay so far with the interaction between these two flags? Okay. Well, we're going to run some experiments here. Okay, I will run some experiments, and then your homework assignment related to this will also have a similar flavor to it. But you will have to do your own commands and stuff like that. But I'll go ahead and do some experiments here. And the first thing is I have to change into the root account and add a user, because it's no fun to do this as one single user. So I'm going to add a new user here, and this user is already existing. So I'm going to use the same folder as before. There we go. All right. So now we have two regular users. One is user, and the other one is Aoyang as a user. Okay. So what I can do now is to do the following. I'm going to change user to Aoyang. And do you think this will ask me for any passwords? It won't, because root is root, and root can switch user to anybody else without permission. So it's not going to ask me for any password. And I'm going to change to my quote-unquote home directory here. And what I'll do is I'm going to create a test folder or test directory using mkdir for make directory. And what I'll do is I'll set it up to 0 and 0. Well, let's set it up to Rx both being 1 first. Okay. So the first thing we want to do is to see, okay, what exactly is the setting at this point? Because it's a folder, if you do a ls and -l on a folder, it will try to display the content inside the folder instead of the details of the folder itself. If you want to show the details of the folder itself, you have to say ls-ld. The D stands for directory, so we want to look at the details of the directory itself. And it is already set up to allow Rx for group owners and also Rx for other owners. Okay, so we'll keep this one up here, and I'm going to open up another shell or another terminal. This is when PuTTY is going to come in handy when you do your homework assignments. Is you can open up multiple terminals and have one being a particular user and the other one being a different user. So I'm here as my own user. I can change my current directory to Aoyang. Okay, no problem. I can even do a ls-l, because the home folder itself is not set up to protect the content, and I can see all that stuff same way as the owner of that particular folder. Okay. As Aoyang, I'm going to create something inside that folder. So I go into test dir using cd or change directory, and I'll go ahead and create a file. The easiest way to create a file is called touch. Okay, so I can just say touch and say ciss342.txt. Okay, that's the name of the file, and I can do ls-l, and it shows me that the file ciss342.txt belongs to Aoyang as a user owner. It also belongs to Aoyang as a group owner. And for group members, they can do a read. For other owners, they can also do a read. And then for the user owner himself, we can do a rewrite. We can change the content of the file. Okay. So my concern is, can somebody else look at the content of this folder? Well, let's try it. Okay. Back here, I am user, and I can do a ls test dir just fine. Not a problem, because both the light switch is on and also the executable flag is on too. But if you just want to look at the content inside the folder or just turn on the light on top of the room, you just need the R flag. Okay, let's check if that it really is the case, because what I can do here as Aoyang, I can change the permission of that particular folder using chmod or change mod or change modifier. And what I can do is to specify O, which stands for other. Okay, it specifies what is this change applying to. It applies to other owners, and minus means I'm removing, and X is the access, the lock access. Okay, and I'm going to do that to this folder, which is a dot, the current folder. Okay, and then I'll do ls-ld dot, and confirm that X is gone now. Okay, because previously we have the X flag here, and now we don't have the X flag here anymore. And as the other user, I'm going to run ls again. Not a problem. Okay, just as expected, because R flag controls the light. The room itself has transparent walls, so as long as you can turn on the lights, you can see what is inside. Okay. I wonder if I can actually see the content of that file. In other words, let me see if I can look at the file, the content of that file. So I'm trying to do a cat tester slash secret1.txt, secret1.txt, and I cannot, because in order to read a book in the room, you have to get into the room to begin with. You have to have the key to the lock. If with the X flag turned off, you lost your key to that lock. So even though you can see there's a book inside, you cannot go into the room to access that book and start to read that book. Am I doing okay so far with that analogy? Okay. So let's flip it, okay? So we'll go back here and we'll use chmod again, but this time I'm going to remove the read access from other, and at the same time I'm going to re-add the execute access to that folder. In other words, I'm taking that the switch away. You can no longer turn on the light to see what's inside the room, but you know what? I'm unlocking the door. So if you know from previous ls commands there's a particular file in this room, you should still be able to walk in the room in the dark and find the object that you want to access. Okay, so we will test whether that works or not. So as the regular user, I want to do a ls first. Okay, excuse me, I pressed the enter key too quickly. I do an ls command first, which means, can I see what is inside this room? The answer is no, because the light switch is off. It is dark now. I cannot see inside the room. But the next question is, can I read this book called secret1.txt? Because from the previous command, I know this book was already there. And the answer is yes. Well, it's an empty file, that's why it didn't show anything. But if it had any content, it would have shown the content. So that's how the X and the R flag applies to a folder. The W flag applies in the way that you can change the content inside the room. Okay, you can add content and you can delete content with the W flag. But what if I want to overwrite that book? Okay, so this is a quick test. Okay, we got 1 minute left. Okay, the question is, if I want to change secret1.txt, what do I need to add write access to? Do I need to add write access to the folder and then the file, or do I only need to add write access to the file itself? In other words, what is the write flag doing to a folder, and what is it doing to the object itself? Okay, I'll explain it first, and then we'll run the experiment. When you apply the W flag to a folder, it means you can move things in and out of the room. Okay, but as long as you're not trying to remove an item from the room or add an item into the room, read access is okay. And X means you can access items inside the room. So as long as you're not removing it, that's all you need. You do not need write access to a folder to change the content of something in that folder. Right? What you do need is the write access flag to the thing that you're supposed to change. In this case, that particular file. So let's go ahead and try it now and see if I can change secret1.txt. So I can say, touch tester slash secret1.txt, and it would fail because it does not have the write access to it. So what I'll do here, as the owner of that file, I'm going to say chmod O plus W. In other words, I'm adding write access to other users to this particular file, and the file is secret1.txt. I'm not doing this to the folder, but only to the item inside this room here, inside the folder. Then I go back to the other account and retry this approach and say, can I touch it? And now I can. Okay, so this is important because it kind of shows you the interaction between the flags of a folder and the flags of the content inside that folder. Okay, so that you know that now you know, even if you mark your folder as RX, so that other people can see it, can access item in the inside, as soon as you change the write permission of the file inside the folder to write also, people can change them now, even though the folder itself seems to suggest otherwise. Okay, so you got to remember that. Okay, what does it mean to each thing, the folder versus item inside the folder? All right. So today's lecture is over. I'm going to give you a new homework assignment based on permission flags and whatnot. The assignment itself, just like your Linux setup of homework assignment, will also contain some additional information, including stuff that we talked about today, and whatever I can throw into the document. So this way, the homework assignment is study material as well. Right. I'm going to stop the recorder and get it uploaded as soon as I can.